Hello everyone, welcome to our last review video. So at the beginning of this video, I do want to talk about the quiz in general and give some advice. So basically this quiz will have 6 questions plus 1 extra question, which is optional. This means that you guys don't have to do this question if you are running out of time or you guys just don't want to do it. And also just don't be stressed out if you don't have enough time to complete this question, because people usually don't do well when they are stressed. So just don't worry about it if you don't have enough time, since it's optional. Okay, so the second point I want to talk about is that functions is still a very important topic in Quiz4. Actually, I would say a relatively important topic because we do have new content after functions. But if you guys are still confused about how function works, please go and figure out how functions work, because we do have questions related to functions in Quiz4, and if you want to do well, you guys need to understand how functions work. And also, when you are practicing questions, please think about modifications of those questions, because we don't put the exact same questions in quiz, but we do put similar questions, but we make some modifications on those questions. So you guys can think about what kind of modifications can we make on those type of questions and practice on your own. And the last point, please read the question description carefully and don't just copy and paste solutions from the tutorials or homework assignments for part marks, because we just give 0 if you copy and paste the exact same solution from homework assignments or tutorials. Okay, so the first topic I want to talk about is how to count the number of occurrence in string. So this example is the question I made in Quiz4 practice. So basically you need to create a function called upper letter score that accepts one input named char sequence and one output named upper score. Char sequence is a character vector that contains lowercase letters, symbols, and uppercase letters. Only uppercase letters have the following values. So A is 26 and B is 25, and it goes on till Z, which is 1 point. So upper score can be computed by adding all equivalent values for only uppercase letters. So let's look at the examples. So if we have the character vector MATLAB, like all of the letters are in uppercase. So if we look at M, the corresponding value is 14, and A is 26, and T is 7, and L is 15, A is 26, B is 25. So we can have the result upper score as 113. So let's look at the second example. So we have all of the we have M, which is an uppercase letters, and all the remaining letters are the lowercase. So in this case, we only count M, and we just ignore all the lowercase letters. So the result upper score should be 14. And if we look at example 3, we ignore the exclamation mark and we ignore the lowercase letter I, and we count H, M, A, T, L, A, T, L, A, B, because they are uppercase letters, and the result should be 132 if you do the calculation. But note that you cannot manually calculate the score and then assign the result. So which means the function should be applied to any character vector. So we cannot just calculate and assign the result to the upper score. And we have a hint here. Built-in function count can be used. How do we use the function called count? So the syntax is count bracket string and pattern. Please note the string here. The string here can be a string array, a character vector, or cell array of character vectors. So it will return the number of occurrences of pattern in string. So let's just give an example. So if we have the char as MATLAB, and we wanna count char as M, and the result will be what? Will be 1, because we have one uppercase M there. And if we change it to a lowercase letter a, and the result will be 2 because we have two a's here. And this is how we can use the function count. So let's see how we can solve this question. We have the given code here, line 1 and line 2. So we have the test char sequence at this, and then we have the line to test if the function we design works or not. You can see that the variable names are different. Test upper score and upper score, test char sequence and char sequence. This is okay because we are using the function we design in line 2, and it's okay to have different variable names. You can actually use any variable names you want because you are using the function you design. But from line 7 to line 18, you have to make sure you only use the input under the function char sequence, and you need to make sure that you have the output upper score in your function. So if you're still confused about this, please check out the announcement we made before quiz 3. It's called clarification for review video for quiz 3. So please check that out if you don't understand it fully. So that is because functions is a still very important topic in quiz 4. So please make sure you understand that part, and we discuss the issue in detail in that announcement. Okay, so the first step here, we want to have the function header. Up score equals to upper letter score charback. Please make sure that you have spelled the function name right. It should be the same as the one in line 2. Please be careful for the uppercase letters and the lowercase letters there. So okay, so next we have values from 26 to 25 to 21. We have a double vector from 26 to 1. So we have 26, 25, blah, blah, to 1. So if you remember from the question description, the values for the uppercase letter A is 26. The values for the uppercase B is 25. And C, 24. And then it goes to the last letter Z, and the value is 1 point. And then we will have like num char. So we initialize it as a 1/26 vector with all the elements as zeros. So basically we want to use this vector to store. We want to store the number of occurrence of each uppercase letter in this vector, and this step is how we initialize the function. Sorry, not initialize the function. How we pre-allocate the vector. So next line, alvec, which is a character vector from the uppercase letter A to the uppercase letter Z. So A, B, C, D, E, F, G to the Z. So if you remember, the 25 will be the uppercase letter A and the 90 will be Z. And then we will have a for loop, which is used to populate the vector numchar. We want to record the number of occurrence of each uppercase letter in numchar. So alvec is 26, the numel alvec is 26, because alvec is a 1 by 26 character vector. And then we count the corresponding letter, each letter. So this for loop will go through 1 to 26, right? So if you look at alvec, it is a 1 by 26 char vector from the uppercase letter A to Z. So it will go through, so alvec bracket I will go through each uppercase letter, and then we use count, and we can have the number of occurrence of each uppercase letter for each time of the for loop running, and then we record the number and the corresponding location II. So basically after this for loop we'll have like 1 by 26 double vector for numchar. And then the first location here will be the number of occurrence of the uppercase letter A. The second one will be the number of occurrence of the uppercase letter B, and third location for C, and the last location for Z. So for example, if we have the task char sequence as our input, if we see the number of uppercase letter A in this char vector, we can see we have 2 A's. So the first location would be 2, and we can see that we don't have any B's here, so 0. And if we see there we don't have any C's, so also 0. And we do that for every letter. And then what's the next? We want to calculate the values for the total values for each letters, right? So we will use the dot multiplication here. So the values is a 1 by 26 double vector. It's from 26 to 26 to 1. So values 1 by 26 double vector. So the values for A, the value for A is 26, B is 25, C is 24, and then it goes on till the last letter, which is 1 point. So what we're doing here is we use the element-wise multiplication here, so we can have the total value of each letter. Sorry. So if we do this, we do the dot multiplication. The first point will be 2 multiplied by 26, which is 52. The second location would be 0 because 0 multiplied by 25, and the third one would be 0 as well, and we do the same thing for the remaining letters. And then the last step is that we only need to sum it, and now we can have the total upper score for all the letters. And that's how we solve this question. The next topic I want to talk about is the application of for loops. I'm not going to cover this topic in detail because we've already covered it in review video for quiz 3, but I do make an example for this question because for loop is still like a big part in this course. Okay, so in this example, the question wants us to compute the number of combinations whose product is greater than 1,000 and assign the result to num 1,000. So let's look at the given code. So we have given vector as numVec, and it is a 1×5 randomly generated numeric vector without repeating elements. And the elements are ranging from 1 to 50, and please note that only two different numbers can form a combination. A number cannot form a combination with itself. So for example, if we have numVec as 10, 11, 9, 8, and 49. 49 cannot form a combination with 49. So 49 multiplied by 49, its product is 2401. This is greater than 1,000, but we cannot count it as a combination because we cannot pair this number with itself, right? So this is not included. And how do we count the number of combinations whose product is greater than 1,000? First, we want to test the product of each combination, and we want to test if it's greater than 1,000 or not. So for the first number 10, how many combinations can we have? We can have 10 multiplied by 11, 10 multiplied by 9, and 10 multiplied by 8, and 10 multiplied by 49. And how many combinations there are for the number 11? So we don't want to pair 11 up with 10 because it's already here, right? We don't want to duplicate that, so we only want to pair 11 with 9, the next number, or you can say the remaining numbers, which are 9, 8, and 49, right? So 11 multiplied by 9, 11 multiplied by 8, 11 multiplied by 49, and the next number 9, 9 multiplied by 8, and 9 multiplied by 49, and the last combination is 8 multiplied by 49. We don't have any combinations for the last number because it's already here, right? We don't want to count it again. We don't want to duplicate that. So here we have these many combinations, and we want to test. So if you like calculate the result, we can see that we don't have do we have any combination greater than 1,000? No, we don't have any combination greater than 1,000, so the result should be like 0 in this case. But if we change, for example, we change this number to 48, and now we can have So we want to change this to 48. Let's change the numbers. And the next one should be 11 multiplied by 48. And 48 and 9 multiplied by 48. And 48 multiplied by 49. If we change that number to 48, now we can have one combination greater than 1,000. So the result in this case should be 1. So how do we solve this question? Okay, so here's the solution for this question. Before seeing the solution, you guys are encouraged to pause the video and then try to solve this question on your own. You can test out your knowledge of for loops. Okay, so let's start. We're still using the same example for numVec, which is 11, 10, 11, 9, 48, and 49. So the first step here, we want to initialize the variable num1000 with value 0, and then we will have two for loops to pair up each combination, right? Okay, so I is going through 1 to 5 because numVec is 5, right? And then numVec I will be going through every element in numVec, and then JJ will be II plus 1 to numVec, and it will go to the next number of numVec II to the last number. So how does this work? So for example, if we have II as 2, so numVec II will be 11, and then I'm gonna write it below, and then JJ will be II plus 1. II is 2. II plus 1 will be 3 to numVec, which is 3 to 5. So here numVec JJ can be the numbers allocation from 3 to 5. So numVec JJ can be 9, 48, or 49. So which means 11 can be paired up with 9, 48, and 49. We don't want to pair up this 11 with 10 or itself 11, because 11 and 10 is already like a combination when we are counting the combination of 10, right? It's already here, so we don't want to duplicate that. So, and that's how these two for loops work. And then we do the multiplication, and we test if the product test is greater than 1,000 or not. If it's greater than 1,000, we add 1 to num1000. Okay, I want to give you guys a hint for quiz 4. So you guys need to understand how these two for loops work when we don't want the combinations of the number with itself, and we don't want any repeated combinations. That's how we can solve this kind of question. We add 1 here because we want to go to the next number. We don't want to go to the number itself or any number before this number, right? Okay, so the next the next topic I want to talk about is called functions and rounding functions. So this topic is a relatively easy topic. So basically, these kind of questions will ask you guys to design a function that already exists. So here is an example. I took this question from homework 1. It's called rounding functions in homework 1. So you guys can review that question again. I made some small changes. I asked you guys to design a function named compute quotient to compute a quotient when you divide dividend by divisor without using the built-in function rem. So this function has two inputs, dividend and divisor, and one output, quotient. So this question is actually exactly the same with the one in homework 1, but the difference is that I asked you guys to design a function. So here is the solution. I don't think I need to explain this question anymore because it's too easy, I think. So I just want to give you an idea. You can practice this on sub question B for rounding functions in homework 1. You can create a function, design a function on your own to do this, and you can actually practice how to design a function with all the questions, I think. So I just want to tell you guys that functions is still a very important topic in quiz 4. So I just wanted to stress that please do understand how functions work. If you don't understand how functions work, quiz 4 will be still challenging for you guys. So please do make sure you can get how functions work. So the last topic I want to cover is how to move the elements. So the question asks you to create a function called leftAce that accepts one input named uppermat and one output named new uppermat. New uppermat is a character matrix with uppercase letters ranging from A to Z. So this function is to move all uppercase letters A's in each row all the way to the leftmost of the corresponding row in new uppermat. The order of the remaining elements which are not uppercase letter A should be preserved and attached to the A elements on the left. So basically all of the A elements should be on the left and the remaining elements should be attached to the A elements. Okay, so example 1. So if we have this, this example is a 4x4 character matrix. So if we do this, we use the leftAce function. So the result should be, the function should help us move all of the A elements to the leftmost. So for example, the first row, the uppercase letter A is already the leftmost letter, so we don't do any changes on the first row. But the second row, we have an A here, so we move this element here to the leftmost location, and then we don't change the order of the remaining letters. It should be M, M, B. So we attach it to the A on the left hand side. And the third row, A is here, so we move the A to the leftmost location and then attach the remaining elements to it. The order should be B, B, U. We don't change the order. And the last row, it doesn't have any A's there in the last row, so we just keep it as the same. Okay. So example 2, this is a 6x6 char matrix. So the first row, we have 3 A's, and then we keep the remaining elements B, J, K. The second row, we move a's to the leftmost side, and we keep the order of the remaining elements, and then attach them to the a's. The order should be MMB. So we do the same thing there, and that's how this function again. Before seeing the solution, you guys are encouraged to pause the video and then try it on your own. So okay, so line 1 to line 3, this is the given code. So basically upper mat text is in n by n character matrix. So if you see from the ASCII table, 65 will be the uppercase letter A and 90 will be the uppercase letter Z. So upper mat text will be in n by n character matrix with all the elements ranging from the uppercase letter A to Z. In line 3, we are testing if the function works. Okay, so functions new upper mat equals left A's upper mat. So the only thing we can access here is upper mat. So that's why we need to, in order to know the dimension of the matrix upper mat, we need to use a function size. We cannot just use n here because each function has separate workspace. You cannot use n because n is not in this workspace. So, and then next line, we're converting the upper mat into type double. And then line 10, because the dimension of new upper mat and upper mat, the dimension of these two matrices will be the exactly same. So we can use NR, number of rows, and NC, number of columns of upper mat to pre-allocate the new upper mat. Okay, so next we will have a for loop going through each row of upper mat double. And then line 14, we're actually checking the number of A's in each row. So 65, the corresponding letter of 65 will be A's. So we're summing it. So we're basically checking the number of A's in each row. And then line 15, we are getting rid of the A's of each row. And line 16, we are concatenating the number of 65s, with the remaining elements, right? Let's say we have a 5 by 5 matrix. And if the first row is Z, Z, A, so the corresponding value for Z will be 90 and 65, 65, 65. We want to move all of these 65s to the left. So the first step here, we are removing it in line 15. We are removing all the 65s, and then what we have in row test are only two 90s, right? So this is 90, 90, but we still want to concatenate the three 65s to the left hand side of row test. So what we're doing is we use the built-in function once, and we already know the dimension of we already know the dimension because we already know the number of 65s from line 14. So we just do 1s 1 comma num ace is 3 in this case. So and we multiply it by 65, and then we can have 65 65 65. So please note here, you don't need to do the dot multiplication because 65 is a scalar, but I just accidentally used the dot multiplication, which is still not wrong. So I'm just telling you guys that you don't need to put the dot here, and it still works if you don't put it there. And now we can have the row we want, and we assign the result to new row. And the next step, we are replacing the corresponding row of new upper mat with the new row. And don't forget, like the last step, we still need to convert the data type back to character, because we converted it to double at the beginning, and we still want to like convert it back.